Today this video is going to be about area of polygons using trig. I would like you to remember some things. You need to find a missing side length of a right triangle. You're always going to use SOHCAHTOA. To find a missing angle, you need to use inverse sine, cosine, and tangent. And you will also need to remember properties of quadrilaterals. The first example we are going to do is example number 1. If you remember back to when we talked about area of regular polygons, we had to always find the central angle. And to find the central angle, we always took 360 and divided by n. N being the number of sides. Now, if we have an octagon, that means we have 8 sides. So we're going to take 360 and we're going to divide it by 8. When we divide it by 8, we're going to get 45 degrees. If we go to your diagram, that means that whole angle is going to be 45 degrees. But we don't want that whole angle. Let's pull that triangle out like we did in the past. We only want half of 45, so that angle is going to be 22.5. Now, we want to figure out the apothem, and we want to figure out that side length of that triangle using what we know. Let's find x first. If we have angle 22.5, that means that we have the opposite side and we have the hypotenuse. So using SOHCAHTOA, which one will you use? Well, we have to use sine. So we're going to say sine of 22.5 is equal to the opposite over hypotenuse. Create a proportion and cross multiply. X is going to come out to be 16.2 times sine 22.5 degrees. When you do that on a calculator, you're going to get around 6.2. Now, since x is only half of that whole triangle that we have drawn in that octagon, we need to double that. To double that, y is going to equal 12.4. So that was pretty easy to find. Now we need to go ahead and find the apothem. There's a couple ways you can do it. You could use Pythagorean theorem now, or you could use trig again. Let's use trig. We have the adjacent side of 22.5 degrees and we have the hypotenuse. So let's use cosine. Cosine of 22.5 is equal to your adjacent over hypotenuse, which is 16.2. Cross multiply. Take 16.2 times cosine 22.5. Z comes out to be 14.96. Now you want to recall how to find the area of a regular polygon. To find the area of a regular polygon, you need to take 1/2 times your perimeter times your apothem. Now we've already done that. We've done that last trimester. We should be able to easily figure out the perimeter. We know what each side length of that octagon is. It's 12.4, and there's 8 sides in an octagon. So we're going to take 1/2, 8 times your 12.4, and then we just found the apothem. The apothem is your z value, and you're going to multiply that by 14.96. If you do that on your calculator, you are going to come out with somewhere close to 742.02 units squared. Looking at example number 2, I'm not going to draw a 12-sided figure, but we can draw that triangle that's going to show up inside. This is our central angle, and to find your central angle, again, you do 360 divided by n. In our case, it's 12. 360 divided by 12, you're going to get 30 degrees. So that whole angle is 30 degrees. Let's drop down our apothem. This angle now is going to be 15 degrees. We don't need that whole triangle anymore. We're just going to use part of it. We also know that the whole side length is 10. If the whole side length is 10 and we're only taking half of that triangle that's inside of that regular 12-sided figure, then this side is going to be 5. Now remember, to find the area of a regular polygon, we take 1/2 times your perimeter times your apothem. We could easily find the perimeter. We just need to find the apothem. So let's put an x value where the apothem is going to show up. Now looking at that triangle in red, we have 15 degrees. We have the opposite side and we have the adjacent side. So that means we have to use tan. Tangent of 15 equals opposite over adjacent. Create your proportion and cross multiply. If you want, you can find what tan 15 is, and then to find x, you are going to take 5 and divide it by tan of 15. Your x value comes out to be, or your apothem, around 18.66 centimeters. Now we can easily find the area. And take 1/2 times your perimeter. Well, we have a 12-sided figure. Each side is 10 centimeters long. And we just figured out the apothem. The apothem is 18.66. So if you look at your note sheet, it's going to ask you for your perimeter. Your perimeter was 120. Now find your area. You are going to get around 1,119.6 centimeters squared. Look at example number 3. What are some properties of a rhombus? Well, if you remember a rhombus, the diagonals are perpendicular, and the diagonals bisect your angles. Diagonals are also bisected. So those are some important pieces of information that we're going to be using today. It's telling us that each side of that rhombus is 6 centimeters. So we can go ahead and label those. And one of its angles is equal to 80 degrees. So if we look at our diagram, the only angles that are going to be equal to 80 degrees are probably B, D, and B. Now if the angles are bisected, that means both of these pieces are going to be 40 degrees. Now let's find x and y. Pull this triangle out. Let's just redraw that. You're going to have x, y, 40 degrees, and you'll have a hypotenuse of 6. So let's use some trig. If we have 40, let's find x first. We're going to have the sine of 40 equals your opposite over hypotenuse. And then to find y, we have to use cosine. We'll have cosine of 40 equals y over 6. Take a minute and figure out what is your x and y value. Right, x should have came out to be 3.86 and y should have came out to be 4.6. Now notice this other property here. Diagonals are bisected. So that means that that part is 4.6 and this part would be 3.86. We can easily find the area of a rhombus now. If you recall the area of a rhombus, it's 1/2 d1 times d2. Now diagonal 1 is going to be the whole length. So let's talk about AC as the first diagonal. When we take 3.86 and multiply it by 2, you are going to get 7.72, so that's the first diagonal. And then the second diagonal's length is going to be 4.6 times 2, which is 9.2. Calculate the area by taking 1/2 times those two diagonal lengths. You should have got somewhere around 35.5 centimeters squared. Look at example number 9 on the back. This is the same type of problem. All of the side lengths are going to be 8. We know that one of the angles is 50 degrees. Well, the only angle that can be 50 degrees is D and B. So we're going to call both of those 25. those triangles out, you're going to have a hypotenuse of 8. We're going to call this x, and we're going to have this as y, and we know this angle is going to be 25 degrees. Okay, let's just set it up. We don't have to solve it. If we want to find x, we're going to take sine of 25. That's going to be opposite over hypotenuse. And then cosine of 25 is equal to adjacent over hypotenuse. When you solve for these values, you can check my work if you would like. X is going to be 3.38 and y is equal to 7.25. Now remember to find the area. You're going to take 1/2 d1 times d2. Take a minute and figure out your area. Pause the video and fill in the rest of the answers, d1 and d2. After you have completed those, you are going to find out that d1 is 6.76, d2 is 14.5, and the area is 49.01 centimeters squared. The next example that we are going to run through is number 4. This is a trapezoid. The only thing that really matters in the trapezoid is this triangle that is highlighted. Let's just redraw that really quick. We're going to have 30 degrees, we're going to have y and h. We need to figure those out in order to find the area of a trapezoid. If you recall the area of a trapezoid, we're going to take half of your two bases, add it together, and then multiply it by the height. We already know our two bases. We can fill that in. 1/2 of 10 plus 16. We just need to know our height now. And you have to use trig in order to do that. If you look at your diagram, we know that this portion of that base is 10 centimeters. We have 6 centimeters left because this whole thing is 16. So 6 centimeters divided by 2, that means this distance down here that's left is going to be 3. So now we can use trig to set this up. If we have 30 degrees, in order to find h, we're going to have to use tan. Tan of 30 equals the opposite over adjacent. Cross multiply, and your height comes out to be 1.73. Now we want to find y. You could use Pythagorean theorem if you want, or you could set up another trig ratio. In order to set up a trig ratio, you would have to use cosine. Cosine of 30 is equal to adjacent over hypotenuse. When you do that, you're going to get 3.46. Now let's fill it in. Let's go back to that area. Area equals 1/2 of 26, and we just found our height to be 1.73. The area of this trapezoid is going to be 22.5 centimeters squared. Now they also want you to find the perimeter. That is the reason why we had to find y. Y came out to be about 3.5. 3.5 is going to be the same on both sides, so we're going to have 7 there. 26 plus 7. Your perimeter comes out to be around 33 centimeters. Example number 5. Find the height of a parallelogram and measure the angle A if the area of the parallelogram is 14 square root of 3 centimeters squared. Now if we recall, the area of a parallelogram is just base times height. It's the same as a rectangle, same as the square. Let's fill in what we know. We know the area is 14 square root of 3. We don't know our base. Actually, we do know our base. Our base is 7. And we don't know our height. So that's where trig comes along. We redraw this triangle. We need to find h first. Well, to find h, let's look at this equation. We see that we have 7h is equal to 14 squared root of 3. You could find 14 squared root of 3 as a decimal, or just divide both sides by 7. Our height comes out to be 2 squared root of 3. If you want that as a decimal, it's going to be around 3.46. Okay, so we have our height. Now we can go back and plug that into our triangle. And then now we can use a trig function to find our angle. Now remember, when we're finding an angle, we have to use your inverse. So if we have angle x, we have the opposite side and we have the hypotenuse. So we have to use the inverse sign of opposite over your hypotenuse. When you do that, that is going to figure out your angle. Angle A is going to measure somewhere really close to 30 degrees. Example 6, measure of angle A is 30 degrees. We're going to use trig here in order to find x. To do that, if we have 30 degrees, we have the opposite side and we have the hypotenuse. So again, we're going to have to use sine. Sine of 30 equals the opposite over your hypotenuse. Now take a minute and find sine of 30 on your calculator. When you find sine of 30 on your calculator, you should get 1/2. So it's saying 0.5 is equal to this fraction. Create a proportion and cross multiply. We're going to have 1/2 of 3x minus 3 is equal to x plus 1. So distribute your 1/2, 1.5x minus 1.5 equals x plus 1. Okay, x is on one side, numbers on the other. Oops, 0.5x is equal to 2.5. When you solve for x comes out to be 5. Now, since we know that is 5, we can easily find angle C. We have two angles of a triangle. Angle C is equal to 60 degrees. And then we just need to find the side lengths. AB, you're going to have to use Pythagorean theorem. AC, you can plug in your x is equal to 5. And your BC, you can plug in your x is equal to 5. I want you to take a minute and do that, and then I want you to find the area of your triangle. Pause the video, and then when you're done, unpause it for the answers. As you can see, those are your answers. We have one more example to complete, and then we will be done. We have an isosceles triangle, ABC, so we have two sides that are congruent. If we use trig here, we can just pull out one of those little triangles, because both of those triangles are going to be exactly the same. We want to figure out what the distance of AD is. So let's call that x. And let's find that first. If to the 80 degrees, we have the opposite and hypotenuse. We're going to use sine. Sine of 80 equals opposite over hypotenuse. Cross multiply. And then that's going to figure out your x. You can also find BD. Let's call that y. Let's redraw this triangle. We have 16, we have y, and we have 80 degrees. This time, instead of sine, we're going to use cosine. Cosine of 80 equals adjacent over hypotenuse. Cross multiply. And you're able to find your y. You also want to find the measure of angle BAC. So that whole angle. If we look at this triangle here, we have 80 degrees, we have 90 degrees. Can we figure out what that angle is? Well, yeah, the rest of the triangle has to add up to 90. So we already have 80 of that 90, so then this angle has to be 10. If both of these angles are completely the same, then angle BAC will be 20 degrees. You also want to find the perimeter. Well, if you have y here, you can find the perimeter there. Just double your y value. You want to find BD, which we are finding, and BC. BC would be the whole side length, or double your y. The next thing you want to do is find your area. So you want to take 1/2 of your base times your height. Pause the video and go ahead and solve for those answers. have all your answers here. AD, BD, BC, perimeter, and area. Take a minute and check those values. You might have to pause the video. For example number 8, your task is to complete this example for tomorrow. This is your quiz to prove to me that you have watched the video. This example is very, 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 very similar to example number 1. If you would like a diagram, pretend that you have an octagon drawn. This is one side of the octagon. Drop down your perpendicular, and the radius is 16 centimeters. So there's your 16 centimeters. The first thing that you're going to have to do is find your central angle. Once you find your central angle, use trig. You're going to need to find your apothem, and you're going to also need to find your side length. That side length is then going to turn into your perimeter. So let's pull that little triangle out like we did in the first 2 examples. We have 16. You're going to be able to find this, and then you'll have x and y, and then you're going to last find your area, 1/2 perimeter times apothem. So that will be due tomorrow. For tomorrow's class, please bring any questions, bring filled out notes, and then we'll be working in groups to practice these types of problems. Remember that you will have a test over Chapter 7, which is similarity stuff. We haven't really reviewed that since before break. And you will also have all of the trig stuff on it. This is the last thing that we're going to do for trig, and we're going to wrap this up on Wednesday. So please have this video watched.